Here we have a working problem with some hard numbers. You see how I have the diagram set up with 45, 60, and 75 ohms in the top, middle, and bottom branch respectively. Our job is going to be to calculate the effective resistance, the current going into those branches, and then rewrite this as a simple circuit. Once we do that, we will go back and figure out the current and power through the top, middle, and bottom branch. So first things first, we are going to do 1 over R1 plus 1 over R2 plus 1 over R3. We'll get a value to that and take the inverse to get the effective resistance. Hit pause and try to do that now. So here we have 1 over 45, 1 over 60, and 1 over 75. We add them together and take the inverse of it, and that'll give us an effective resistance of 19.15 ohms. Now that I have the effective resistance and the total voltage, I can find out the current. V equals IR, rearrange, I equals V over R, and get a value. Here we see that the current going into the junction is 1.253 amps. So effectively, this is what that circuit looks like. If I were to simplify it and draw it as just an effective schematic, I would have the power source, the effective resistance, and the current going through. Now we're going to go back to the more blown up schematic, and we're going to figure out the current and power through each branch. All right, let's remind ourselves that the voltage is the same across each branch. So for the top, middle, and bottom, they will each have 24 volts across those resistors. Finding the first current, we're going to take that voltage of 24 and divide it by its resistance of 45 and get 0.53 amps. Hit pause and try to figure out I2 and I3. Okay, doing the same method of the total voltage of 24 divided by that branch resistance. I2 is 0.4 amps, I3 is 0.32, and when we add those three up, I1 plus I2 plus I3, sure enough, we get our 1.253 amps as we had found prior. Now let's try to find the power in each branch. So at this point, since you know the current and you know the resistance and you know the voltage, by all means, you could use any formula you would like for power, IV, V squared over R, or I squared R, and you'll get the same exact value for what the power is in that branch. I chose V squared over R. And in doing that, you see the power for the first branch is 12.8 watts. And at this point, hit pause and try to figure out P2 and P3. Okay, so P2 and P3, we follow the same method. Depending on the formula that you chose to use, you would plug in the proper numbers. And here I found 9.6 watts and 7.68 watts to be the power in 2 and 3 respectively. When we add them up, we get a 30.1 watt. So power will always represent the conservation of energy. And here we have 30.1 joules per second, which is a watt, as the power across those branches. If I were to find the power somehow else by just using the totals, right, instead of adding the three together, I could have used my total values to also figure out power, the total current times the total voltage, and that also would have given us a 30.1 watt value. This is just another example. I tried to make a shorter video, and I hope it helped.